Welcome to The Explainer. Today, we are taking an absolutely incredible journey right up into Earth's orbit. We're going to be looking at a massive, literally looming threat right above our heads and a groundbreaking technological solution that honestly sounds like pure science fiction but is actually happening right now.
Okay, let's dive right into our roadmap for today. We'll kick things off by understanding the space junk crisis. Then we'll meet the unprecedented ISAJ-1 mission, we'll check out the incredible double orbital ballet it performs, and finally we'll explore the brand new frontier of space maintenance. Section 1. The danger of space debris, a looming threat.
So we need to zoom out for a second and look at the massive, completely invisible problem circling our planet right this very minute. Just take a look at this staggering number. More than 30,000. That's the estimated amount of dangerous space debris, specifically stuff larger than 10 centimeters, that's currently clogging up Earth's orbit. We're not just talking about pebbles here. These are substantial pieces of solid metal, old rocket stages, and dead satellites just flying blindly through space.
And here is why that number should genuinely terrify you. These objects travel at several kilometers per second. At those hypervelocities, they aren't just floating junk, right? They are high-speed projectiles. A collision at speeds like that can completely vaporize a vital, active satellite, which could instantly cripple our communications or GPS networks down here on Earth. And even worse, they directly endanger space stations and our manned missions. Which brings us to a really scary concept, the Kessler syndrome. This is essentially a catastrophic scenario where just a single collision creates a massive cloud of fragments. Those tiny fragments then hit other satellites, creating a cascade of destruction that exponentially increases the risk of even more collisions. Ultimately, it could render entire orbital lanes completely unusable for generations. It is quite literally the ultimate doomsday scenario for our space environment.
Now, you might be wondering, what are we doing about this? Well, current countermeasures mostly just involve international guidelines. Things like deorbiting satellites at the end of their life or pushing them out into a designated graveyard orbit much further out in space. But, those are just preventative measures for the future. They completely ignore the massive wrecks that are already out there, spinning totally out of control. We desperately need a more active solution.
Section 2. The unprecedented ISAJ-1 mission, an unprecedented task. To tackle this crisis head-on, I want you to meet the hero of our explainer today, the ISAJ-1 mission. Developed by the Japanese company Astroscale, weighing in at 650 kilograms and scheduled to launch in 2027, this spacecraft is gearing up to do something we have literally never seen before. Its core objective is to perform detailed visual inspections of dead satellites. It comes packed with high-precision thrusters and state-of-the-art imaging systems. You can kind of think of this spacecraft as an orbital detective. It's going to get right up close to these silent space wrecks to figure out exactly why they failed, gathering all sorts of clues that our ground telescopes simply can't see. The ISAJ-1 has two massive, specific targets on its hit list. First up is ALOS, which launched back in 2006. This thing is huge. It weighs 4 tons, which is literally the size of a city bus. And it mysteriously lost power back in 2011. The second target is ADOS-2, launched in 2002. It's slightly lighter at 3.7 tons, but it's positioned in a significantly higher orbit. Both of these are dead, massive, and incredibly dangerous if we just leave them unchecked. Section 3. The double orbital ballet, a complex choreography. So, how exactly does it manage to reach them both? Well, the execution requires an unprecedented sequence. Step 1. The ISAJ-1 approaches ALOS, observing from a safe distance before really carefully closing in. Step 2, it completes a highly detailed visual inspection. Then comes Step 3, which is the real challenge. It actually has to perform a highly complex orbital change maneuver. Finally, Step 4, it approaches and inspects the second target, ADOS-2. I honestly cannot overstate how incredibly difficult it is to approach these tumbling, dead objects. I mean, they have no navigation aids, no docking ports, and were never designed to be visited by another spacecraft. So, here is the crucial takeaway. If they pull this off, it's going to be a historic first. It'll be the first time a single spacecraft successfully serves multiple clients on completely different orbits during one single mission. Proving that a spacecraft can essentially hop between different orbital highways to do a job, that totally changes the game for commercial space operations. It proves that it's both economically and technically viable. And the real-world value of getting this up close and personal is immense. We gain insights that go way beyond the capabilities of any ground-based telescope. It helps our engineers understand the precise root causes of satellite failures. That means we can design much more robust satellites in the future. But crucially, mapping exactly how these dead satellites are tumbling lays the essential groundwork for actual physical in-orbit repairs and active debris removal later on. It basically turns a giant orbital mystery into actionable engineering data. Section 4. The New Space Frontier, a booming new economy. This single mission is sparking an entirely new paradigm in outer space. Think about it. In the past, in-orbit servicing was this incredibly rare luxury, reserved pretty much exclusively for manned missions, like astronauts visiting the International Space Station. It was dangerous, and it was incredibly expensive. But the future? The future belongs to private companies deploying autonomous, robotic spacecraft to perform these super complex tasks safely, efficiently, and completely unmanned. This shift is creating an entirely new orbital market right before our eyes. ISA-J1 is paving the way, with inspection, for sure. But soon, we'll see robotic spacecraft actually refueling satellites to extend their life, literally replacing defective components in the vacuum of space, and actively grabbing and removing debris. In fact, Astroscale is already partnering with the German launcher ESAR Aerospace on their upcoming ELSA-M mission, which is going to be a dedicated debris removal demonstrator. This whole revolution represents a monumental paradigm shift, and I think it's best captured by this quote right here. Satellites will no longer be disposable objects, but assets that can be maintained. Just think about that for a second. We're moving away from a mindset where we treat multi-million-dollar state-of-the-art machines as disposable trash the second they break. Instead, we're starting to treat them as valuable, maintainable assets. That is a game changer for our presence in space. So, I'll leave you with this final thought today. With autonomous robots capable of repairing and refueling multi-ton machines in the dark, freezing void of space, what will a fully sustainable space economy look like in the next decade? It's basically a sci-fi reality unfolding right before our very eyes. Thank you so much for exploring this fascinating topic with me. Keep wondering, keep learning, and I'll catch you on the next explainer.